Dear colleagues, my name is Natalia Loukashevitch. My main work is Research Computing Center, Moscow State University, and I'm also head of the department in computational science department in Moscow State University, and also I'm professor of philological faculty in MSU. So, and today I might talk about neural information retrieval. So it is information retrieval based on neural networks. And I would like to say that during in our group, we have a very long story of our group. And information retrieval system is one of our main interests because we create information analytical systems for various organizations. This is in Russian models in Russia. They describe how different tools should be, how diverse tools should be connected in different information analytical system. And of course, basic subsystem of any analytical system is information retrieval system. And we have in our group our own system developed for several years ago. And in the left side describes some of our experiments. We began many years ago. We participated in a famous track conference. This is a well-known conference on information retrieval evaluation. And also we participated also many years ago SUMA conference, and were the first in some track, and also we organized for in Russia together with other people, and also Yandex of that time, not current Yandex. So-called RAMIP workshop. RAMIP workshop is about information retrieval evaluation for the Russian language, and also I was a participant of organizing committee of cross-language evaluation forum. This is also was information retrieval evaluation conference. And it was interesting when 2005 I presented a talk about survey of Russian tools and in NLP and information retrieval. They thought that only bears are walking during our streets, but it was impressed that how many interesting instruments that time we also had for the Russian language. So I think many of us see that there are many interesting methods and techniques currently in information retrieval. And we also again return to information retrieval, to studies in information retrieval. And also I will mention today our new benchmark for testing information retrieval system in Russia. So let's begin. Of course, most of you know that basic models for information retrieval during many years are lexical methods. And most known are TF-IDF technique for comparison of queries with documents. And currently, more mentioned technique formula is so-called BM25. You can see here formula. It's maybe less known outside of information retrieval. So it's a summation of weights. The first multiplier is IDF, and then kind of TF in some form with parameters, and also some averaging averaging on length of document is very also important. So it's back of words models below back of words, you can see. And the main problem is that so-called vocabulary mismatch when query is expressed some words, but relevant documents are expressed with other words. So, example, почему электрические батареи быстрее разряжаются на холоде? Maybe relevant answer can be батарейки быстрее садятся на морозе. It's very difficult for lexical methods to match these two phrases. In Russian and English, I translated more similar, but in Russian, very, very different. During development of information retrieval, we see many different approaches to overcome this lexical mismatch. The first direction is so-called query expansion, when some methods used to add additional words to queries. For example, from some thesaurus to find somehow similar words, or maybe to methods based on reduction of retrieval space. So if we imagine initial retrieval space, this is below the words, and the documents, it's huge matrix of which describes how words were mentioned in specific documents. It's very this sparse matrix is not convenient for analyzing semantic similarity between query and documents. And below in the right, you can see mention of narrow embeddings. So what we see during last year that different approaches are proposed to encode somehow text and queries using different neural network methods. So today I would like to discuss latest approach, maybe 2, 3, 4 years, last years, and what neural embeddings can be discussed in different papers. How large language models can be used in different during different stages of information retrieval, and also new benchmarks for evaluation. If we look through information retrieval papers, we can meet several frequent words such as B-encoders, cross-encoders, and below re-rankers. So some of these words, such as re-rankers, were already mentioned at our conference. So the idea is how to encode queries and documents on some training collection to do queries and relevant documents more similar in some vector space. So you can see two main approaches, B-encoder and cross-encoder. And cross-encoders are often used as re-rankers. So I will go to cross-encoder and I will describe difference between these methods. Excuse me, this should be cross-encoder, so it was hurry and played. This is cross-encoder. Cross-encoder, in the title, cross-encoder, sorry. So the idea of cross-encoder is that we use BERT and allocate query and sentence in BERT as BERT tokens, and then train model to classify if sample text fragment is relevant to query or not. So it's a very first example of cross-encoder. You see date of publication 2019. immediately after appearance of BERT, colleagues proposed this cross-encoder. So this very effective approach, but it's usually take much time because it's no offline encoding. Therefore, for each query and each document, we should load this query and document to BERT, and then use a pre-trained classifier to classify to relevant or non-relevant. So it's not a fast procedure. And these authors showed on a large MS Marker dataset. I will describe this dataset in the next slide. That the performance of this model is 2 and 5 times better than BM25. And let's look at the dataset. So this is currently a very famous dataset, MS Marker. Why it's famous? Because it was prepared by Microsoft Bing group. They collected 100,000 user queries in form of questions, and then provide passages, and then organized crowdsourcing procedure to annotate these passages. So this is a real information retrieval needs from users, real questions, real queries, and the manual annotation of relevant documents and relevant passages. So this is huge data set, and since 2016 is used for training various neural retrieval models. So if we continue after this slide, I will show the result on MS Marker. So another stage of cross encoder, and also next stage of re-ranking is so-called pairwise ranking, when BERT as a model obtains query and 2 documents, and this model is trained to predict what document is more relevant to query. So in fact, this so-called duo BERT has more information about query documents, pairs of documents. In fact, in classical information retrieval, this pairwise ranking, for example, for Yandex in 2010, 2020, before BERT, it was the best ranking, this pairwise ranking. So you can see in the picture that first classical re-ranking. So first some simple model, some fast model as BM25 backwards model is used to provide some initial ranking. Then, for example, 100 documents, here 6 documents, are re-ranked by cross encoder, such as MonoBERT shown before, so query and document, and then classification relevant or not relevant, and with what probability. And then the most relevant documents then again re-ranked by duo BERT, when this picture, yes, in the right below, when query into documents, addition is picture free documents are re-ranked to find the best ranking for the initial part of retrieval page. So what results? So we see MS Marker, and Anserini BM25 is one of most effective implementation of BM25 with with the best parameters. So then this is a table from initial paper. So we see that monobert addition re-ranking by monobert based on initial ranking by BM25 significantly improves the results, and then authors try to do the next stage re-ranking, adding different variants of duobert, but you see that the improvement is not great, but the first stage improvement is very, very significant. It's very impressive. And it seems that the time of BM25 is finished, maybe, but not. Again, let's continue and then return to this question about ending BM25 or not. Also continue this topic with re-ranking. Also, we can find papers about use of relatively small generative models such as T5. When the model trained on the queries such as on the data such as query could document there relevant or not. So it was again trained on large MS marker data set, and then the model is trained to predict this true or not true or false label. And models results are ordered according to probability of true label. So you can see that BM25 again this is the first very fast stage, and then re-ranking, and you see that several variants of T5 models and quite large model as a relatively large model among T5 models provides real improvement. About MRR is the inverse place of the first correct answer. So if the answer is on the correct answer is on the second place, then MRR is 0.05. So you can see that mainly if BM25 gave the first correct answer mainly on the fifth place, yes. So neural models give neural re-ranking models give correct answer about place to the second or third. So okay, you see currently the, even more improvement in comparison to BM25, but you should understand the following: these models are trained on specific data set. It's MS marker, it's huge MS marker. But if we will take this model, we will apply these models to our data, to our queries. So we never will have such data as Microsoft Bing has, and therefore it's very important to understand if this model can be transferred, yes, to other data, to other queries. And this question about transfer of neural information retrieval model was set by developers of so-called benchmark Bayer in 2021. They said the following, that yes, we see how neural networks models can improve performance results, but they improve this their answers result on the same data sets. Yes, so of course the set are divided into training part and test part, but these training and test parts are comparable. So, but we're not interested to repeat, to work with that data set. We have our own local data, our own local queries, local user needs. So these splendid, excellent models which showed excellent results on that MS market data set, if this model will work in our data. So benchmark BEAR was created to check this, to answer this question: how trained models work in zero-shot format. So if we take any trained model, maybe on MS Marker, then we try apply this model to another data with shorter or longer queries. Yes, with longer or shorter documents, and we can compare these models with even with BM25. So below you can see some pictures, and I will show them in more detail. They really created a benchmark that is data set from different domains, different types of queries. And here we see such tasks as fact-checking, as argument retrieval. This is, yes, of course, it's information retrieval related tasks, but they are very diverse. It's also news retrieval and question answering and tweet retrieval and biomedical information retrieval and entity retrieval. The task is to find relevant entity. So this is yes, this is description of BEAR benchmark. So top line is MS Marker. All models are all neural models are trained on MS Marker. Then trained model is applied to all next data sets. Performance is calculated, and then we can calculate average quality or average performance on that data set and compare if real progress in neural networks models in comparison to very old BM25 model. So it's very interesting, impressive results. 2021 again, I remember. You can see in the first column BM25, and then different models proposed that time in comparison with BM25. So it's good models, they discussed models, but nobody at the time did not test them on a diverse data set. These authors applied models trained on MS Marker to this diverse benchmark. And what they have that among single models, BM25 continues to be the leader. Maybe this only small improvement, 106 is only what they have. And only last column shows the use of cross encoder. You can see BM25 plus cross encoder, and this two-stage model gives 11% of improvement. So it's very important. It was a very important work, that show that the real situation we had that time. So we can understand this that many machine learning models are difficult to transfer to another to other data, to other maybe similar tasks. But you can see this for information retrieval. It's very important to have models which can be transferred to another data, because all these splendid models are trained on large data set. We all never have such. And let's return to the encoder, and then return again to the results. So the encoder, in contrast to cross encoder, they are trained offline. They're trained before real search. The first encoder, at least very known encoder, is sentence BERT. When two encoders are trained on a natural language inference task. It's not an information retrieval task, but this is some kind of the first one of the first known approaches. When we have some task, we have training data, and using this data, we can train cross encoders. So why cross encoders may the use of cross encoders gives less time. So in fact, before real search, offline model is trained, then trained to be query more to encode queries to be more close to relevant documents. And then these vectors are loaded in some vector database. And when in real search online, you should only to extract vectors from vector database. So it's more fast procedure than cross encoding. So this is the first approach on nature. It's not information retrieval task, but the idea of encoding B encoders in that sentence BERT. Then very known model lab. Don't know how to pronounce it. LabSIE we say, but I don't know. So this is cross-lingual encoder, which trained on parallel text more than 100 languages. They extract parallel sentences and then train encoders to do vectors on different languages closer to each translation in vector space. So again, we see source one text, two encoders, is some similarity measure between two vectors. So these layers are trained to do similar translated text more similar to each other than not translation. And one of the best models, and was also mentioned today, I think, E5 model. It was model of 2023. It was specially trained in this. It's being encoder and specially trained for information retrieval task. The first, they began not from MS marker. They tried to find in internet some data which can be treated as queries and relevant text, for example, from Reddit, Common Crawl, some questions and answers in different forums, which were labeled as good answers. For example, they crawled a lot of huge data set of queries and pseudo-relevant documents and trained again B encoder, and then additionally trained on manual datasets such as MS Marker and NQ natural question dataset. This is a dataset of question answering, and the natural language inference again to do the results to find the similarity between queries and the documents better. And this 2023, it's maybe December, you can see that E5 also demonstrate the results on the same Bayer benchmark. And again, you can, you see right side three variants of E5 model. It's smaller or larger encoders, some variants of BERT. I will show later this because we will apply this for Russian. And you see that BM25 is best on 5 dataset, even such huge, such interesting model as E5 special model for information retrieval. And BM25 performance is 41 and 7, and the best results of E5 is 44, averaging on all datasets. So it's very, very, very interesting that we see progress on neural network approaches, but we see that BM25 that we can see that many work should be done in some combination, maybe lexical and neural approaches to find better results. So looking on this interesting evaluation, we decided also to create a Russian benchmark for evaluation on information retrieval and try to collect the most diverse data set as it was done for initial Bayer benchmark. So we took data set automatically translated from Bayer. Then we tried to find existing multilingual data set with the Russian language, which are suitable for information retrieval task. Also, we try to find information retrieval related existing Russian datasets. And also we created some new datasets based on Wikipedia. And let's look, it's again a huge table. So the first block is translation from Bayer. Of course, we should have for comparison, yes, some similar data sets from the Bayer benchmark, and also some data set with Miracle, XQuad, XQuad sentences, SQUAD. This is dataset multilingual question answering. Of course, question answering is related to information retrieval. This dataset we already translated into Russian. And then we also find some Russian dataset, RUFACTS, RIA-News, RUBK, SberQuad, Russian. This dataset we created is Russian. And also we extract is Wikipedia so-called interesting facts. So in Wikipedia, so we created new dataset in our benchmark. And let's look at evaluation of different models on this benchmark, Russian. So, so what we try to apply, this is currently we can demonstrate only known models, but we can compare how these models work in for Russian. So you see 3 variants of multilingual E5. So you see that a small model based on small encoding models such as Menelium. And then base is based on XLM Roberta base. E5 large, XLM Roberta large. Also, in 2024, Chinese model, Chinese encoder, also currently well-known BGE, as I say it such. User BGE is Russian English variant, which additionally train on Russian. So we can also compare with Labs-E, encoder that was created for machine translation. And we can see also two variants of Russian models created by Sber researchers. So we can compare this model on our new benchmark, and also we use re-ranker. And we can see on the Russian data how the first 100 documents were ranked by special re-ranker. Again, huge table, sorry. But so what we see online different data sets we collected. Then bold font is the best result for each data set, and you can see all best results are in the right part. This means that all best results were achieved by re-ranking. So you see BM25 plus BGE E5 plus, this means the following: the one model, lexical or B encoder is the first stage, and then cross encoder is applied for the first 100 documents to rearrange first documents. If we look on the left side, this is highlighted some results. This is best single models, best single result without re-ranking. We can see that even now, 1, 2, 3, 4, about 5 data sets have the best results achieved by BM25. Yes. Of course, if compare 3 variants of E5 model, the best results, of course, achieved by larger models. And Labs-E, let's look at Labs-E. It's encoder, yes, B encoder, but it was not intended for information retrieval task, but for machine translation, and is not good for information retrieval. Results are very low. No, because Labs-E was trained on similar sentences, similar number of words. Yes, it's another task, but for information retrieval, usually query is shorter than text, so Labs-E is not cannot give the best results here. Never, very low results. And interesting that the best result is single models achieved by latest Freedom model. Freedom model is from Sber, some Sber group. Recently was published on Hugging Face. We see that the average result 56, about 56. This is NDCG, so-called NDCG metrics. And if compared to BM25, BM25 is about 48 average results. It's not huge improvement, but if we compare with re-ranking, again, this is the best result achieved with, again, this specialized Russian model 3D. With re-ranking, it's about average quality about more than 60%. It's significantly already better than initial BM25 model. And you can see also that, again, BM25 and re-ranking is also gives great significant improvement, about 8% in comparison with initial BM25. So also in our conference we could hear such words as re-rankers, because it's really very powerful instrument to start from some simple models and then re-rank more complicated and time-consuming model. So this is a new benchmark. It's already published. It's available on Hugging Face, and the paper is published yesterday, maybe. Let's return. I have last part of my presentation, so let's say several words about application of large language models. It's of course very large topic, but I will say several directions. Here I use one of interesting figures from paper 2023 about that stage is when large language models are applied in information retrieval. These models are applied in all stages. So, for example, we can reformulate queries, or maybe use a language model as a retriever, but it's usually expensive, or maybe as a re-ranker. It's possible. And then, of course, reader we see is Yandex Neira. Is this example of reader when some model is retrieves documents, and some summary of documents it's created is example of reader. So several words about this application of large language models. We can return to very old topic of expansion of queries or documents. So you can ask currently large language model to reformulate query, to create paraphrases, and all these paraphrases to use to answer to search relevant queries. Or very interesting direction when it's called expansion of document. Expansion of document means the following: we ask the model to answer the query. For example, write a passage that answers the given query. What are the initial symptoms of COVID-19? So the model generates answer. It's maybe not very good, maybe not with some errors, mistake, but this document can contain very useful words, and these generated documents then use as query to search for relevant documents. Because it's very difficult to find correlation between the word symptom and, for example, fever or sore throat or something like this. And therefore, if we generate additional document, we can use it as additional query. This is example of expansion of queries, reformulating. Also, a very interesting approach when we use a large language model as re-rankers, and this is example of list-wise ranking. So the model is asked to re-rank passages. Again, the first stage we use some simple model BM25 or B-encoder to generate the best documents, and then we can ask large language model to re-rank list-wise. Model can see not only one single document or two documents. It can see several documents, not all 100 documents, because it's too much for input. But you can see example how how researchers propose use so-called window. So first the model begins re-ranking from the last documents, for example, from 8 or 10 documents. Then they can find the best documents, such as document 8 and 5, and then compares these documents with previous, and using this re-ranking, using this window re-ranking, it's possible to obtain the whole re-ranking of these first 10 documents. And this zero-shot format, no additional training. These large models are asked to re-rank. So let's compare. This is the work 2024, I think. So we see a significant improvement, and this re-ranking is, again, I can repeat, it's not trained at zero-shot format. So how it can be seen, a gray this color of initial BM25. SOTA is T5, the best T5 re-ranker which was proposed previously. And then author asked two models such as ChatGPT and GPT-4 to re-rank, and then you see that there are improvement without any training on the dataset. It's maybe cheaper to train model, but again to train T5, it's smaller model. But it's we should currently we can select to ask some large model, or maybe to use pre-trained model. But pre-trained model is also always used trained on some other dataset, not our. So, and also this is practically my last slide. As it was mentioned already today, maybe several times, that of course one of important direction of information retrieval development currently is so-called retrieval augmented generation, when we all understand that knowledge in generative models are static, and it's not enough for answer questions about our local documents or about current state of news or something like that. And therefore, it's a very interesting combination when all the best achievements on information retrieval are combined, are loaded somehow to generation system, trying to improve the model generation, model answers, and this is very hot topic of studies. But for my presentation is a next story. Today I will finish, and this is my conclusion. Currently, narrow language model, narrow encoders maybe a very interesting stage for development of information retrieval. So we can see many different application of encoder, encoders, re-rankers, large language models. All these models are based on neural networks. And at the same time, we need many benchmarks to understand quality of each model of each stage for searching in specific conditions, specific data. And yes, large language models are actively discussed as zero-shot application for different roles. And of course, it's retrieval augmented generation is very novel application, and we can think about many new results in all this area. Thank you for your attention.
Thank you for your presentation. RAG systems are very interesting for recent 5 years, but we still do not have working cross-encoder in Russian. What do you think? Why don't we have it? Or are there any data sets that we can train it on? Because
what means we do not have cross-encode? So, in fact, it's maybe said or good that international cross-encoders, such as this Chinese cross-encoder, improves significantly initial ranking. Therefore, it works. And another question that I don't know why, but we could not create our national Russian model, which the best. But you see, Frida currently, it's very interesting that we found Frida in the very last moment of our computations, and we were sure that the winner will be Chinese model. It's BKE. It's approximately the same results. You can see 56 and very close this E5 large. But you see that our Russian Sber group, from Sber group variant, it's available on Hugging Face. It's provides simply slightly better, slightly better results. So our people also are working on the models, and you see that.
I'm sorry, and these results were obtained on Russian language?
On Russian language, this is Russian model, Frida. Yes, this Russian language, Russian dataset. Frida is specially created for Russian language. I don't know, maybe it can be used also for English, but it's yes, it's based on Fred T5, and then so specially additionally trained on Russian. So you see the result of Russian training. And also you see that the overall result are the best result also based on this is Swiss re-ranking. Frida plus Chinese re-ranker is the best here. So we should more optimistic.
Thank you. Other questions? Yeah.
Thank you for your speech. Could you repeat, please? Can your benchmark be used for evaluating retrieval augmented generation systems?
In fact, we use here metrics called NDCG. This NDCG metrics measures how relevant the best retrieved documents. Current metrics do not evaluate the correct answer. So in retrieval augmented generation, we should evaluate the next stage. So we found the best documents, but we should answer the question or answer to some task. Yes, so it should be implemented additional metrics for RAC evaluation, and it's evidently that if we extract from this dataset question answering datasets, it can be easily applied to the next stage of evaluation, to retrieval augmented generation. So, for example, we have so here, if we even take question answering dataset, we evaluate not correct answer. We evaluate that the model could find text with correct answer. It's information retrieval task. But in generation, we should answer. So in fact, here we cannot measure answers, but we measure retrieval. But if we extract from this data benchmark question answering dataset, we can additionally to implement metrics for retrieval augmented generation. So we should measure if the answers improve when we provide additional text retrieval results and so on. So it's the first stage for the next stage, maybe.
Thank you.
Thank you for your speech. I have a few technical questions regarding this table. So if we don't use re-ranking, then our results are rather straightforward. So we take the best result by cosine similarity, and that's just one result. But if we use re-ranking, we can return different amount of results for BM25, for BGE. Also, we can use combination of results returned from BM25 and BGE. So my question is, how many results you've returned in your re-ranking tests, and have you tried to combine BM25 results with E5 results and then apply BGE to get what is the total average result?
So, as we said, we took 100 first 100 documents for re-ranking. Yes, it was question. First 100 documents re-rank. So of course it's possible to combine some scores, yes, from different models. But this assemble model, it can be maybe, of course, but it's more and more complicated, and it's maybe on different data sets, maybe, for example, we should tune some coefficient, some kind of linear combination. It's a very simple approach. Of course, it's possible, but here it's first. So it's possible to combine any models as voting scheme to calculate average scores and many different ways of combinations between based on all models. But this. We only test this approach as an initial model and then re-ranking. And maybe we also used two re-rankers, but E5 re-rankers and BGE re-ranker, but it's not, this didn't improve the results. So it's what we have currently. I shown everything to you.
It would be very interesting to see the results for this benchmark, because practical usage, as I understand, is when you combine both results from BM25 and BGE, because BM25 better works for some particular terms or names retrieval, and E5 better works for some context.
Yes, but this is a complex model. It maybe should be already tuned on specific application and tasks. It might be very gives very different results on different data sets. Therefore, it should be tuned on specific data. And so, okay.
Okay, thank you.
Thank you. I don't see any questions from the audience, so I would allow one question from me, if you allow. I agree with previous question regarding this combination of BM25 and the neural approaches. In practice, we, as a company with a product, we have some issues with, say, named entities with retrieval augmented generation. And how do you see how we can improve this on the retrieval and maybe on generation part also. Thank you.
So about the named entities.
Yeah, named entity as a first place. So like, I don't know.
Yes, I think that from our analysis of results, we could see that the more encoders can miss important named entities. So that yes, we should have some additional tools for controlling that mentioned named entities should be somehow expressed in the answer. I agree with this that named entity control is important, but here on this large benchmark we can see many diverse data sets. Some data sets and some queries do not include many named entities. Therefore, this is a general benchmark, of course, for companies, and for specific search it's very important to control named entities. And I think that maybe combination with some knowledge graphs, because may be very important, because in some queries we can see that in query people, some user ask about Russia, but a good answer mention Moscow or maybe Novosibirsk or maybe another city from Russia. So we can maybe we can use some kind of query expansion or knowledge graph. So I think that we are in the beginning of a new stage on information retrieval studies, and we should combine different. As the previous stage, Yandex in 2009 implemented system MatrixNet, where they introduced thousands of features, and now again we on the next level. Not only Yandex or Google, we now ourselves can integrate different features. And thank you.
Yeah, thank you, Natalia.